Hello. Suppose we have a function, f of x, in the form of a polynomial. For example, 2x to the fourth power minus x cubed minus 3x squared plus 6. And we want to calculate the value of this expression for some x, for instance 4. Now of course we can substitute 4 for x in the expression and get the correct answer. But there are two problems with this. First of all, exponentiation, which is of course repeated multiplication, is a very time-consuming process, especially for large exponents. And secondly, the chances of error get rather high when the coefficients or exponents get even moderately large. So we need a faster method. Luckily there is one. Horner's method allows us to perform such substitutions quickly, easily, and very efficiently. So let's take a look at it. To use Horner's method, we need to build the grid. This grid consists of 2 rows. And as for the number of columns, we take the degree of the polynomial, which is its highest exponent, in this case 4, and simply add 1 to it. In this case, we get 5, so we have 5 columns. Like so. Next, we fill out the top row with the coefficients from the original expression. Recall that the coefficient is simply the number before the variable term. So, for example, the coefficient of this term would be 2, and we write it down here. The coefficient of this term is negative 1, we write it here. The coefficient of this term is negative 3, we write it here. The coefficient of the x term is 0 because it is not present in the expression, so we write a 0 here. And lastly, the coefficient of the constant term is 6, so we write it here. Next, we write to the left of the grid the number that we wanted to substitute, in this case 4. And in this cell, in the bottom left cell, we simply write what's on top of it, in this case 2. So now it's time for the real calculations. Here is the algorithm we use to fill each remaining cell. We multiply the number that we wanted to substitute, in this case 4, by the rightmost number in the bottom row. And then we add the number that is on top of the cell we want to fill in. Let me give you an example. What do we write in this cell? Well, we multiply the number 4 by 2 and add negative 1, or simply subtract 1. And we get 7 as a result. We write it down here. Now for this cell, we multiply 4 by 7 and get 28. 28 minus 3 is simply 25. Now for this cell, 4 multiplied by 25 is 100, and 100 plus 0 is simply 100. Next for this cell, 4 times 100 is 400, and 400 plus 6 is 406. Now that we finished filling the whole grid, the rightmost number in the bottom row, 406 in this case, is the answer. So we can write it up here. Notice that if we would substitute 4 for x in the expression above, we would get the same answer, 406. In fact, you can try that out yourself. But Horner's method allowed us to perform this operation quickly, easily, and efficiently, eliminating the need for exponentiation, which in big expressions is a very time-consuming process. Thank you.